Chapter 5 discusses why, what, and how of database processing. It begins by describing the purpose of databases and explaining important components of database system. Next, it gives an overview of creating a database system and your role as a future user. From the Gear Up employee discussion, 1. Illustrates how database can be used to facilitate decision making. 2. Show creativity and innovation in processing data to obtain desired result. 3. Show the value of information when avoiding mistakes. Chapter 5 Study Question. Question 1. What is the purpose of database? Question 2. What is a database? Question 3. What are the components of a database application system? Question 4. How do database applications make databases more useful? Question 5. How are data models used for database development? Question 6. How is a data model transformed into a database design? Number 7. What is the user's role in the development of databases? Question 8. MIS in 2024. What is the purpose of a database? The purpose of a database is to keep track of things. Database keeps track multiple themes. In case of student database, it stores and can show student grades, student emails, and student office visits. Usually, lists of data involving a single theme can be stored in a spreadsheet. Lists that involve data with multiple themes require a database. What is database? A database is self-describing of integrated record. In Chapter 4, we learn that a byte is a character of data. In database, byte grouped into columns, such as student number and student name. Columns are also fields. Column or field are grouped into a row or a record. Finally, a group of similar rows or record is called table or file. Therefore, a database is a group of tables or file plus relationship among the rows in those tables plus spatial data called metadata that describes the structure of the database. Relationship among rows. Figure 5.6 shows sample of data from the three tables: email, student, and office visit. The data in the three tables are connected by student number column. Several spatial terms are used to express these ideas. A key, also called a primary key, is a column or a group that identifies a unique row in a table. Given a value of a student number, you can determine one and only one row in student table. For example, only one student has a number 125. Every table must have a key. The key for the email table and office visit table is visit ID. Sometimes more than one column is needed to form a key or a unique identifier. Student number is a foreign key in email and office visit tables. This term is used because such columns are key, but they are key on a different or foreign table than the one in which they are reside. Metadata. Metadata are data that describe data. Figure 5.7 shows metadata for the email table. The format of metadata depends on the software product that ID processing the database. The presence of metadata makes database much more useful. Because of metadata, no one needs to guess, remember, or even record what is in the database. What are the components of database application system? Figure 5.8 shows the component of a database application system. Such system make database data more accessible and useful. What is a database management system? A database management system is a program used to create, process, and administer a database. As with operating system, almost no organization developed its own database management system. Instead, companies license database management system product from vendors such as IBM, Microsoft, Oracle, and others. Other popular database management system product are DB2 from IBM, Access and SQL Server from Microsoft, and Oracle Database from the Oracle Corporation. Other product database management system is MySQL, an open source database management system product that is license free for most applications. Creating the database and its relationship, database developer use the database management system to create tables, relationships, and other structures in the database. Processing the database. The second function of the database management system is to process the database. Such processing can be quite complex, but fundamentally, the database management system provides application for 4 processing operations: to read, to insert, to modify, or to delete data. Structured Query Language, or SQL, is an international standard language for processing database. SQL can also be used to create database and database structures. Administering the database. The third database management system function is to provide tools to assist in the administration of the database. Database administration involves a variety of activities. Database management system can be used to set up a security system. In addition to security, database management system administrative function include backing up data of database data, adding structures to improve the performance of database application, removing data that are no longer wanted or needed, and other similar tasks. How do database applications make database more useful? A database application is a collection of forms, reports, queries, and application programs that process a database. A database may have one or more applications, and each application may have one or more users. Figure 5.11 shows 3 applications used at GearUp. Buyer used the first one to schedule event. Operation personnel used the second to set up the graphic and action term and screens. And accounting personnel used the third to process even financial result. These applications have different purposes, features, and function, but they all process the same GearUp event database. What are forms, report, and queries? Figure 5.2 shows a typical database application data entry form. Figure 5.11 shows a typical report. Data entry forms are used to insert, modify, and delete data. Report query data using the database management system and display the result in a structured context. Database management system programs provide comprehensive and robust features for querying database data. Figure 5.13a shows a query form in which a user types in a keyword for which he or she is looking for. Figure 5.13b shows the result of the query. Why are database application programs needed? Forms, report, and queries work well for standard function. However, most applications have unique requirements that a simple form, report, and query cannot meet. Application program process logic that is specified to a given business need. In the student database, an example of application is one that assigns grades at the end of the term. If the professor grades on a curve, the application reads the breakpoint for each grade from a form, and the processes each row in the student table, allocating a grade on the breakpoints and the total number of points earned. Another important use of application program is to enable database processing over the internet. For this use, the application program serves as an intermediary between the web server and the database. The application program responds to events, such as when a user presses a submit button. It also reads, inserts, modifies, and deletes database data. Multi-user processing. Figure 5.11 and Figure 5.14 show multiple user processing in the database. Such multi-user processing is common, but it does not pose a unique problem that you, as a future manager, should know about. Loss update problem exemplifies one of the special characteristics of multi-user database processing. To prevent this problem, some type of locking must be used to coordinate the activities of users who know nothing about one another. Locking brings its own set of problems, however, and those problems must be addressed as well. Enterprise database management system versus personal database management system. Database management system product fall into two broad categories. Enterprise database management system product process large organizational and workgroup databases. This product support many, possibly thousands of users and many different database applications. Personal database management system products are assigned for smaller, simpler database application. How are data models used for database development? Because the design of database depends entirely on how users view their business environment, user involvement is critical for database development. Database structure can be complex, in some cases very complex. So, before building the database, the developer constructs a logical representation of database data called a data model. It describes the data and the relationship that will be stored in the database. It is akin to a blueprint. Just building architect create a blueprint before they start building, so too, database developer create a data model before they start designing the database. Figure 5.16 summarizes the database development process. Interview with users leads to database requirements, which are summarized in a data model. Once the users have approved or validated the data model, it is transformed into a database design. The design is then implemented into database structures. What is Entity Relationship Data Model? The Entity Relationship or ER data model is a tool for constructing data models. Developers use it to describe the content of a data model by defining the thing or entities that will be stored in the database and relationship among those entities. The second, less popular tool for data modeling is the Unified Modeling Language or UML. Entities. The entity is something that users want to track. Example are order, customer, salesperson, and item. Some entities represent a physical object, such as item or salesperson. Others represent a logical construct of transaction, such as order or contracts. Usually, entity names are always singular. Entities have attributes that describe characteristics of the entity. Example attributes of order are order number, order date, subtotal, text, total, and so forth. Example attributes of salesperson are salesperson name, email, phone, and so forth. Entities have an identifier, which is an attribute or group of attributes whose value is associated with one and only one entity instance. For example, order number is an identifier of order because only one order instance has a given value of order number. For the same reason, customer number is an identifier of customer. If each member of sales staff has a unique name, then salesperson name is an identifier of salesperson. Figure 5.17 shows example entities for the student database. Each entity is shown in a rectangle. The name of the entity is above the rectangle, and the identifier is shown in a section at the top of the entity. Entity attributes are shown in the remainder of the rectangle. For example, entity advisor is an identifier called advisor name, and the attributes are phone, campus address, and email address. Relationship. Entities have relationship to each other. An order, for example, has a relationship to a customer entity and also to a salesperson entity. In the student database, a student has a relationship to an advisor, and advisor has a relationship to a department. Figure 5.18 shows sample department, advisor, and student entities that their relationship. Diagram on figure 5.18 are too cumbersome to use in database design discussion. Database design use diagram called entity relationship or ER diagrams. Figure 5.19 shows ER diagram for the data in figure 5.18. A line is used to represent a relationship between two entities. Notice the line between department and advisor represent one-to-many relationship signify that one department may have more than one advisor, but an advisor has at most one department. The line between advisor and student represent many-to-many relationship because one advisor can be related to many students and that a student can be related to many advisors. Figure 5.20 shows the same entities with different assumptions. Here, advisor may advise in more than one department, but a student may have only one advisor, representing a policy that students may have not multiple majors. Figure 5.19 and 5.20 are typical examples of ER diagram with a crow's foot diagram. The crow's foot notation shows the maximum number of entities that can be involved in a relationship. Accordingly, they are called the relationship maximum cardinality. Common examples of maximum cardinality are one-to-many, many-to-many, and one-to-one. Another important question is, what is the minimum number of entities required in the relationship? For example, most a student have an advisor, or must an advisor has a student to advise? Constraints on minimum requirement are called minimum cardinalities. Figure 5.21 presents a third version of this ER diagram that shows both maximum and minimum cardinalities. The vertical bar on a line means that at least one entity of that type is required. The small oval means that the entity is optional. For example, the relationship need not have an entity of that type. Therefore, in Figure 521, a department is not required to have a relationship to any advisor, but an advisor is required to belong to a department. Similarly, an advisor is not required to have a relationship to a student, but a student is required to have a relationship to an advisor. Also, note that the maximum cardinality in Figure 521 have been changed so that both are one-to-many. Database design is the process of converting a data model into tables, relationship, and data constraint. The database design team transforms entities into table and express relationship by defining foreign key. There are two methods available: normalization and the representation of two kinds of relationship. Normalization is process of converting poorly structured table into two or more well-structured table. Consider the employee table in Figure 5.22a. It lists employee name, hire date, email address, department number, and department name. If one of the department name is changed, then all old department name must be changed to new department name. It is possible that not all old department name will be changed to new department name. The inconsistency in this table is called a data integrity problem. Some rows indicate the new department name and some other rows indicate the old department name. Data integrity problems are serious. A table that has data integrity problem will produce incorrect and inconsistent result. User will lose confidence in the data, and the system will develop poor reputation. Information system will poor reputation become serious burden to the organization that use them. The data integrity problem can occur only if the data are duplicate. An easy way to eliminate the problem is to eliminate the duplicate data. We can do this by transforming the table design in Figure 522a into two tables, as shown in Table 5.23. Here, the name of department is stored just one. Therefore, no data inconsistency can occur. The general rule of normalization is to construct table such that every table has a single topic or theme. The problem with the table design in Figure 5.22 is that it has two independent themes, employee and department. The way to correct the problem is split the table into two tables, each with its own theme. In this case, we create an employee table and department table as shown in Figure 5.23. Figure 5.24 shows the step involved in transforming a data into a relational database design. First, the database designer creates a table for each entity. The identifier for each entity becomes the key of the table. Each attribute of the entity become a column of the table. Second, the resulting tables are normalized so that each table has a single theme. Third, represent relationship among those tables by using the foreign keys and add additional table for many-to-many relationship. What is the user role in the development of database? Users are the final judges as to what data in database should contain and how the records in the database should be related to one another. Thus, user review the data model is crucial. When a database is developed for your use, you must carefully review the data model. If you do not understand any aspect of it, you should ask for clarification until you do. Entities must contain all of the data you and your employees need to do your jobs, and relationship must accurately reflect your view of the business. If the data model is wrong, the database will be designed incorrectly, and the application will be difficult to use. MIS into 2024. With cheaper data storage and communication, we can be sure that the volume of database data will continue to grow, probably exponentially. All that data contains patterns that can be used to conceive information to help business and organization achieve their strategies. Amazon determined that relational technology would not meet its needs, and it developed non-relational data store called Dynamo. Meanwhile, for many of the same reason, Google developed a non-relational data called Bigtable. Facebook took concept from both of these systems and developed a third non-relational data store called Cassandra. In 2008, Facebook turned Cassandra over to open source community, and now Apache has dubbed it a top-level project, or TLP, which the height of respectability among open source projects. Such non-relational databases have come to call NoSQL database, where NoSQL means non-relational database that support very high transaction rate processing relatively simple data structure, replicated on many servers in the cloud. Use of this NoSQL product has led to the definition of new type of data source. Big data is used to describe data collection that are characterized by huge volume, rapid velocity, and great variety. Today, some of the major challenges are finding and reporting patterns and relationship in big data stores. NoSQL databases are used for this purpose, along with another open source product named Hadoop. From this development, we can observe three possible trends that are likely to be important in 10 years. First, none of the NoSQL system was developed by a software vendor such as Microsoft or Oracle. They were developed by hugely successful companies that had business requirements unmet by relational database management product. Most companies would not be able to afford the cost and risk of such development. It is possible that complex, feature-rich, custom software will be continued to be created by non-software companies. Second, having developed Cassandra, Facebook turned it over to the open source community, thereby demonstrating that it values data more than software. Is this another trend? Is the business of licensing software for profit disappearing? We see other evidence that Google gave away Gmail and G+. Microsoft gave away Office web apps. And both Microsoft and Google gave away their mapping application. Will more organizations create important software and provide it free to users? If so, does this reflect a trend for the future of the software industry? Finally, big data collection will continue to grow, but right now, only highly trained computer scientists can run NoSQL database management system or Hadoop. Considerable information is buried in big data store that organizations cannot use because they do not have enough professionals to find it. Unlike many business professionals today, they can learn to query and report data from their DBMS. It is impossible for them to query and report from a big data source. At least the situation is true by 2014. However, by 2024, it is quite likely that a new product will exist that allow business professionals to process big data. Is that an important opportunity? Building such software may not rewarding if market dynamic force the new software to be given away. But being on the leading edge of business professionals who learn how to use software to find important patterns and relationships in data could give you highly compensated skill and strong competitive computer advantage. This is the end of chapter 5.